Okay, so for 9.2 of Honors Algebra 2, we're going to do the reciprocal function. The reciprocal function, we're going to look at the graphs and how the graph and the equation are related to each other. How's the graph moving up, down, left, and right on the coordinate plane depending on what the equation is. So the reciprocal function we have here is 1 over x. So we have f of x equals 1 over x. And the graph, like we had in chapter 7, looking at the parent function of what the general shape of that graph is going to be, we're going to do the same thing here. The general shape we have here, the exponential decay function going in the upper right-hand quadrant here. It's not hitting the x-axis, it's not hitting the y-axis, it's getting very close, and the same thing in the lower left, the third quadrant. It's getting very close to the x-axis, very close to the y-axis, but it's not touching. That's not be important. I'm going to be looking for that when you do your graphs, making sure that does not cross those axes. The center point here is at 0, 0, and 2 points I'm going to be looking for is 0.11. When you have a point going through, that's going to be one of the few exact points that we're going to have on here where both the x and y are going to be integer values. So I'm going to be looking to have 1, 1, and -1, -1 also goes through there. So I'm going to be looking for your center point and that those 2 points are somewhat accurate when you're drawing these graphs. Now looking at the parent function, a lot of this is going to be the same, how it moves left and right. So you're going to be looking at, we have the same variables here. The group here in the denominator, x minus h, okay, and that's going to be just like when we had grouped in the vertex form. In the parentheses, it was x minus h squared. Now it's in the denominator. And the a, again, could be written out front of this fraction, but again, multiplying fractions, we just move that a in the numerator. The a is still telling us if it's going to be shrunk or stretched. Okay? If a is greater than 1, it's going to be stretched. Less than 1, it's going to be shrunk. So you're looking for that value of a to tell you by what factor is it getting shrunk or stretched by. If a is negative, so you're going to be looking for a negative sign. If a is negative, there's a graph is going to be reflected across the x-axis. Now looking at that parent function, we had it in the upper right quadrant, so it was up and to the right and down and to the left. If it's going to be reflected, it's now going to be up and to the left and then down and to the right. The h value, like I said, is moving. It's grouped with the x, so it's in the denominator. That's telling us the left and right movement. Now remember, when you are graphing these, when you're looking at it, it's going to seem opposite. X minus h. So if you had this as, if the h was say -3, you could rewrite this as x plus 3. So you have to be careful and know that when it's x plus 3, you'd be moving 3 spots to the left. And k here is telling us our vertical movement up and down. And k is going to be whatever sign it is. Plus is going to be up and minus is going to be down. So a couple examples here, the graphs. We have f of x, 1 over x minus 3 minus 4. So what I like to do is I like to start with that center spot. That would be our original starting point. Now since it's x minus 3, okay, minus 3 is going to be 3 spots to the right. So that's our h here. That's moving 3 spots to the right. Our minus 4 is moving 4 spots down. So there's our new starting point. Now, like I said, when we looked at the parent function, the axes are not going to be touched by a graph. So I sometimes like to just redraw those at our new point or starting point. And that's where our parent function or our function is not going to be touching those. So when we draw these up and to the right, remember I want to pass that 1 point there. Not hitting the axes. And there's that graph, or at least our new axes when we once move our point, and then down and to the left. And there's our graph. So that's the movement that we had. Went to the right 3 and then down 4. Okay, so there's one example. Another example here is f of x is -1 over x plus 4 plus 2. So again, I'm going to put my starting point, 0, 0. And the negative we're not worried about later. We'll worry about that after we have our starting point. So first let's do the x plus 4. x plus 4 is going to be 4 spots to our left. 1, 2, 3, 4. And 2 spots, the plus 2 is moving 2 spots up. So there's our new starting point. I'm going to make my axes again, just so I have an accurate graph when I do draw it. Now I'm going to worry about that -1. The -1 means it's being reflected. So instead of up and to the right, we're going to go up and to the left. Okay, we're being reflected on the x-axis. So this bottom part, that was down and to the left, is now up. And the one that was up top and to the right is now going down. So we have up and to the left and down to the right. So there's our graph for that one. The reflection is flipping it over the x-axis. And again, we moved 4 to the left and up 2. Now the other thing you're going to be asked to do in this section is, if given the equation, describe what the equation is telling us, or describe what the equation is doing to the graph, or would do to our parent function. So here we have f of x equals 3 over x minus 9 plus 12. Now I said before, when we did this in chapter 7, you could either do bullet points or have it in paragraph form. Make sure you're looking at all of our pieces. We have the 3 up top in the numerator, x minus 9 is in the denominator, and at the end there we have we have just plus 12. Okay, so in this case, the graph is being stretched by a factor of 3, moves to the right by 9, and moves up by 12. Okay, the stretching and shrinking is going to be up top. Since it's greater than 1, it's being stretched by a factor of 3. 3 is greater than 1. What's being grouped with the x, that's our left and right movement. So we have x moves to the right opposite by 9 and moves up by 12. That's the back end of the plus 12 is telling us that we're moving up. No negative sign, so it's not being reflected. F of x equals -0.9 over x plus 6. So this time we have our negative sign. This is 0.9, and it has x plus 6 here. The graph is being reflected by the x-axis, being shrunk by a factor of 0.9, and moves to the left by 6. Okay, so make sure you tell us the factor. It's less than 1, so it is being shrunk. It's being reflected on the x-axis, and since it's x plus 6, it's going to be moving to the left. Remember, x plus 6 is actually x minus -6. Okay, so that is going to be it for 9.2.